This is Statistics Unit 2, Practice Test Answers. Okay, so first of all, this is the multiple choice practice test that we had, and I've got the free response one right after this. Okay, let's look at here. The best estimate of the standard deviation of the men's weight displays in this dot plot. So let's go ahead and check out the dot plot. So I noticed that the dot plot is about a normal distribution. And so the middle looks to be about smack in the middle of this. So I'm going to guess and put it, just first look, looks like it would be about 20 with this standard deviation. But when I look at the answers, I see obviously it can't be 40, it can't be 10, and 20 would be in the middle of these, and it's not 15, or it's either, it's 15 or 25. So the way I'm going to test which one it's going to be is basically, remember, with 1, 2, 3 standard deviations, I want almost all my data to be contained on the third standard deviation, but I need a little bit more past it. But when I try to check out 15, so what I do is I take my mean that I think I have about, and I add 3 standard deviations to 15, and I get 205. Well, 205 is going to be about right here. And 115 is going to be about right here. So I still have quite a bit of data that's left out. So 15 is just a little bit small. So when I try 3 standard deviations times 25, so this is the mean, plus 3 standard deviations times 25, because I'm guessing maybe it might be 25. We know it is because you see the answer, obviously. But I get 85 and 235, and on that case, that definitely is going to contain all of it much better. So that's why I'm going to go ahead and say it's 25. Okay, for number 2, let's talk about why this would be true. Fewer or no patients will have a body temperature more than 3 standard deviations. That's, yes, absolutely definition of what 3 standard deviations is few or no patients, which we looked at above, is that on your normal model, you're going to have 1, 2, 3, 1, 2, 3, and you can see that this model is low down here because there's not many people that are more than 3 standard deviations away. So yes, that is true. The histogram for these temperatures will be roughly symmetric. I'm going to say yes, it's going to be roughly symmetric because with body temperatures, most people are right around the average temperature of 98.6. But if you measure people's temperatures, they're going to have a little more or a little less, but most of them are going to be right around here. And so you're going to have it, about here where it tails off, and you have very few people that have less than anything further than left or right. Not a lot of outliers that are going to be super far on here with human body temperature. So I say it's 1 and 2. This one, exactly, here's the problem with this one. Exactly, I'm going to make it red because it's bad. The word exactly is the bad part. 68% will be within 2 standard deviations of the mean, and that's the other part. Because this would be within 1 standard deviation, because remember my curve is at 68% is 1 standard deviation, 95 is the second, and 997. And the other problem is that it's never exactly, or rarely exactly, but it's not expected to be exactly. So you could have it approximately. Okay, number 3, you don't have to know anything about what viscosity is or Pascal seconds or anything of this chemical process. What you need to know is the z-score. So this is the z-score, is 1.77, and I need you to know what the definition of z-score is. The definition of z-score is is number of standard deviations above or below the mean. So a sample that has fluid of a z-score of 1.77 means that it has a standard deviation of 1.77 above the mean. And when you look at B, oh, goodness gracious, B is not the right answer. I don't know how I highlighted that. A is the right answer. A exactly describes it. B, C, and D all describe something that's completely different, that's talking about viscosity being 1.7 pascals or something. But no, you need to say the z-score is just that many standard deviations, bigger than the mean because it's positive, would be smaller than the mean if it's negative. Has standard deviation of, no, and this is not how many, that's not what the standard deviation is, that's how many standard deviations are. Standard deviation, we don't know what the standard deviation is. We do know that there are 1.77 of them. Okay, the reason it's ACT is because you could describe this model as the average ACT score is around a 22. Maximum ACT is a 36. Minimum, I think you can score is a 12. And most people are going to score in the middle. You're going to have a little bit higher, a little bit lower, but it's going to be like this. Income and monthly mortgage can be described the same way. Most people in our area in Pearland make between $50,000 and $200,000. That's average-ish what people usually make here in this particular area. But obviously, you go to more affluent areas or Hollywood or business owners, CEO, you've got Mr. Tesla, Mr. Microsoft, Facebook, all these different things. They're making, mega millions, or athletes way out here. So anyway, it would be skewed to the right. Monthly mortgage, that's the price of your house that you pay a month. So that's going to be the same idea. Most of our houses around here, big mansions are going to be, so this would be skewed to the right. iColor is categorical, so it could never be considered as a normal model. So just cross that one out. Okay, this number 5 is just like number 1, but this one actually is a little bit easier. It makes it a lot bit easier because when you go into the center, you've got 14. I'm going to do it the same way I did the other one. I'm going to say, okay, this looks like 2. And look, and 2 is already the answer. So 2, 2, 2, you can see after 3 standard deviations out, 3 standard deviations out, most of the data is contained, and that's what you want. Which are most likely to follow normal model? Gender is categorical, so cannot be that. Length of the hours in the surgery of the hospital. So the way I look at this is when you think about a surgery in the hospital, most surgeries are about 2 to 4 hours. But then you have your crazy, crazy long surgeries, that are complicated. Heart surgeries, brain surgeries, some terrible accident where they have to do a lot of repairing on the patient. And those are the ones that are going to have outliers. So you're going to have most of them are 2 to 4 hours, like over here. And then you're going to have some outliers. So that's going to be skewed to the right. Hours worked per week by U.S. adults. Well, for this one, I think you're going to be skewed to the left on this one because most people work between, let's say, 40 to 50 hours. Maybe even we go to 40, 60 hours. But you're going to have your outliers of people that don't work at all. So that's going to be, I think, skewed to the left. You really can't get many more hours a week because you have to sleep. You could work 80, 90, 100, 120 hours one week, but that's not going to be sustainable. So it's going to be just skewed to the left. Blood pressure, the reason being is because and notice it's males in their 30s, so it's grouping similar males. Because if I said blood pressure of all males, then I have to talk about what happens to older people or babies or sickly people, things like that that are not in their 30s because they're not healthy. That's what most men in their 30s are pretty healthy. So most of their blood pressure is going to be really, really similar. In fact, I did a quick survey of the people in my class today, and I said, gentlemen, raise your hand if your blood pressure is high. No one raised their hand. Raise your hand if your blood pressure is low. No one raised their hand. Because I've got a group of healthy young men, and so their blood pressure is probably all pretty similar and a little bit higher and a little bit lower, and that would be probably a normal model. Okay, and remember, a normal model is where 68% of my data is within 1 standard deviation, 95% is within 2 standard deviations, and 99.7% is within 3 standard deviations of the mean. So on this one, it says, what's expected to be more than 1 standard deviation? Well, more than 1 standard deviation is this area here. And if 68 is in the middle, more than 1 standard deviation, that's not right. That one's going to be the right. Because more than 1 standard deviation is going to be this part here. And so the 68, that's going to be 16%. And that's going to be 16%. That's why I had 32 that was marked, but it's not that because it says more than 1 standard deviation away. So that's going to be 16. Okay, the lifetime of a smart tone battery. Okay, this one is just the most difficult one, and if you have one like this on your test, it will be a bonus problem. You can do it. It's just a little bit more steps. So for this one, you have, it says the middle 95%. So that's what you know. And you know that this value is 8.5 hours and this value is 11.5 hours. All right, so for this one here, you are going to need to find the z-score since you don't know the mean and you don't know the standard deviation. So I have a normal model, the mean, standard deviation, and I don't know either one. I don't know them. So we're going to find the z-score for what this value is right here, and that value is this percentage right here. That percentage, if this is 95%, that means I have 2.5% on the tails. So I want to find the z-score for 2.5%. I'm going to find that in just a second. And that's going to be equal to observed value, which is my 8.5, minus my mean divided by my standard deviation. I don't know my mean. I don't know my standard deviation. I'm going to do the same thing to this one here, the 115. So I need this value. So if you notice, I have the 95%, but then I also is included to this 2.5% because my chart and my calculator start here. In order to get all the way over to 11.5, I had to pass the 2.5%, pass the 95%. So that's a total of a z-score of 97.5%. So we're going to look that up also. And that's 11.5 minus mean divided by standard deviation. Okay, so let's go ahead and look at those percentages. I'm going to show you two different ways. One way you could look up in the chart of 0.025 and find it, and also 0.975, and you can find it. And you can look up the chart, and the chart meaning you look up 0.025 to the closest one possible and find out your z-score by finding the z-scores here. I'm going to use the calculator, and the calculator use inverse norm. And you're going to use this as the area. The mean and the standard deviation are 0 and 1. The reason being is this is how to get a z-score. So let's go over to our calculator. And I already did it here, actually, inverse norm. I'll just show you how I did it. I got negative 1.96 and positive 1.96, but I went menu, stat, distribution, inverse norm. And on the area, that's what I put 0.025, 0 and 1, and there's my negative 1.96. I did the same thing with 97.5%, and I got 1.96 on that. So I have this here is negative 1.96 and this is positive 1.96. So I'm going to just put these right here. Okay, so now I have two equations to unknowns, and if you would like to substitute, use substitution, you absolutely could do that. So to solve it by hand, I would multiply both sides by s for this. So those would cancel out, and I would get negative 1.96 times s equals 8.5 minus mean. All right, and of course, I could solve for s. I could divide by 1.96 and then put s into my other equation. But I'm just going to show you how to put it in the LinSolve in your calculator. So the way we're going to do that is I'm going to get positive 1.96. So I'm doing the second one. Times s equals 11.5 minus mu. All right, at this point, I just need this to stay here. At this point, we're going to go ahead and get our calculator, and I'm going to type both of these equations right here. Equation 1 and equation 2 into our calculator. Except I'm just going to make it easy for us. Instead of s and m, I'm going to use x and y. So I'm just going to type those into my calculator. So bring your calculator up and go menu. You're going to go to algebra, solve. Uh-oh, I'm on the wrong one, sorry. Try that again. Menu, algebra. I have a different one. That's right. Mine says solve systems. Yours is going to be linear solves, so it's going to be the one beneath. It's the third one. So I got LinSolve, and I'm having them x and y. So I'm going to just type in LinSolve. The other way you can do it is you can literally type in LinSolve like this. But yours is a little bit different than my calculator, so you would be menu, algebra, and right below solve, you're going to have yours. You're not going to have all of these here, but you're going to have solve systems. Okay, so I'm going to go ahead and type these in. Now, the calculator does not like the denominator right here. That's why I multiplied it here. It doesn't like it, so I just multiplied it on both sides to get it up in the numerator. So I'm going to do negative 1.96 x. As I said, I'm going to have my x be, oh, you know what? I forgot. I'm not going to use x. I'm going to use n because I'm going to use n and r because my x and y are already spoken for something else. But you should be able to use x and y. Mine are programmed in for something else. So equals and I'm letting this be N. Just let me show you. This is going to be N, and this is going to be R. Just doesn't matter. You can use anything you want. I just have mine pre-programmed. 8.5 minus R is what I'm going to do. So 8.5 minus R. And then 1.96 N equals 11.5 minus R. Okay, and I got to change this since I'm not calling it X and Y and I'm calling it N and R. I'm going to N, comma, R. Enter. Okay, so my first one is 0.76 and the second one is 10. So my N, which is the standard deviation, is 0.76 and the mean is going to be 10 because that's what I got in my calculator. So you can see that's exactly what we got for B. In a normal model, you're going to approximate what percentage of observations are equal or greater to one standard deviation below the mean. So I want one standard deviation below the mean, but I want everything greater than. So that's this percentage. And remember that one standard deviation below the mean, that one standard deviation is 68%. And this here is 16%. And this here is 16%. So you can add 68 plus 16, and that's where I get the 84%. And number 10, in a normal model, what is the z-score expected to have approximately 97.5% of observations above it. So it says above it. So basically 2.5% below, right? So if I go 0, -1, -2, that's 2.5% because remember, the middle is 95%. So that means that's going to be 2.5%. So it's saying what observation has 97.5% above it, and what value is that? Right here at -2. Okay, so that's the first part. Let's look at the second part. Suppose that a normal model describes students in a history class. Parker has a standardized score of 2.5. This means that Parker's score is, this is the definition of standard deviation like I just described, 2.5 standard deviations above the class average. Great. The heights of Dutch men have a mean of 184, standard deviation of 8. The heights of French men have a mean of 174 and a standard deviation of 7.1. Which of the following is the back-to-back histogram that represents these heights? Well, then the Dutch men, they're going to be higher than the Frenchmen. So the first thing is that you're going to see, let's cross out which ones we know can't be it. Well, this here shows like the Dutchmen and the Frenchmen have the same. They look like they're the same mean. So that can't be it. And this one here looks like the French is higher than the Dutch. So that can't be it because we have the Dutch is going to be higher. This one's definitely higher. But let's see what the problem is because we already know that A is the right answer. So for this one, it says a standard deviation for the French of 7.1. So if I take the 174 and I'm going to go out 7.1, and you can see this last value is close to 200, but if I say plus 3 times 7.1, that's going to be 21.3, and I have 174. And that's going to be 3, 5, 9, 195. So that's right about here. But I'm going to have the same thing here for the French. But the Dutch, the Dutch is higher. And you can see that that's potentially here. But then the standard deviation is 8. And so if I'm here at 184 and I'm adding plus 8 times 3. So that's 184 plus 8 times 3 is 24. And that gets me about 208, which would bring me out here. And clearly, that's just not the right one. If you do the same thing here, you're going to get the right answer because you can see that the Dutch is slightly higher than the French, which is what we have here. And the spread is really similar. The Dutch is going to be a little bit more spread out than the French, but you can see on this one, that was part of the problem, is the Dutch was only this far, yet the French were this far. And when you look at I have mixed up the colors, sorry. I should have it as yellow here and pink here. Yes, because the French, you can see, have a larger spread in D here, but in reality, it should be the opposite. The yellows do. So this is why this is not right. For this one, you can see the Dutch has a standard deviation about, a spread about that far, and the French has about this far. So you can see the French has a little bit wider spread. The reason we know it's going to be a little bit wider spread is my standard deviation right here. It's going to go 3 standard deviations up, 3 and down, and so it's going to be really pretty similar. Okay, so which of the following variables would most likely follow a normal model? Selling prices of houses in Arizona. Well, if you're comparing Arizona to Arizona, this is again same thing I think we talked about earlier. It's going to be a right skewed where you've got most of your houses are, I don't know, $300,000, $400,000, $500,000 for the suburban type area. You're a little cheaper in an inner city type area, and then really expensive for the mansions that they have out there. So that's why it's not here. That would be A, would be skewed to the right. The weights of small order fries at a local restaurant. Okay, so if I don't know if you've ever worked at a restaurant, but I used to work at Dairy Queen, and we had to make sure that our ice cream cones were pretty similar in size, because you didn't want, let's see if I can make an ice cream cone. Whoop, loop, there you go. And we had the little Dairy Queen swirl, there you go. Anyway, you didn't want someone coming in and having one ice cream cone here, and then someone else coming in, oh, that's pretty bad, sorry, having this huge ice cream cone and pay the same, because they'd come in, why they got more than me? So the weights are going to be, this is a French fries, my example is ice cream cones, but you're going to get a very similar amount of weight for the French fries, which you should. So most of them are going to be the same thing. You're going to have a little higher, a little lower, and so that's the way it's going to be. Scores on an easy test. If it's an easy test, you're going to think that it's going to be skewed here to the right, or excuse me, to the left, because that means you're going to get like 90 to 100, a lot of high ones, but then you're going to get your occasional person that didn't study or do their homework or do what they're supposed to do, and they're not going to do well. Family income, we've talked about that, is going to be skewed to the right because you have your average people here and then people that make a lot of money to the right, which isn't very often. Okay, using the information in question 2, so go back to question 2 where I have the mean information of the Dutch and the French. Who's taller? If I have a Frenchman, let's see, Frenchman is pink and Dutchman is yellow. So a Frenchman and so what we did is took the Frenchman and we computed his z-score of 2.82 and the Dutchman of 2.5. And how did we get the z-score? Because the z-score is equal to your observation minus the mean divided by the standard deviation. And I got the Frenchman is 2.82 according to his race relation or cultural relation, and the Dutchman was 2.5. So because the Frenchman had a higher z-score, he is then considered taller in respect to his culture. So this is how you're going to want to label the 1, 2, 3 standard deviations. You're also going to put normal model. This would have been 100, 15. So this is how it's going to be scored on your test, where you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points. Now let me show you. Remember, the 100 is right here in the middle. The 15, the way you do the 15 here is add 15, add 15, add 15, subtract 15, subtract 15, subtract 15. And then within 1 standard deviation is 68%, within 2 standard deviations is 95%, and within 3 standard deviations is 99.7%. Okay, use your drawing to answer the following work. So it says, what percent of adults have IQ between 70 and 130? So 70, let me just get rid of all this stuff. $70 and 130 is here. And that's 2 standard deviations, so that's 95. 85 and 15, so 85 and 115. So that's 1 standard deviation, that's 68. And greater than 115, so that's going to be on the outside of 68. So that's going to be 16, because the reason it's 16 is because I have 68 on this side, 16 here, and 16 here, because add 16 plus 16 plus 68, and that's going to get you 100. What are the IQs of the lowest 16%? So the lowest 16% is going to, I already have 16% labeled from here, and this is the lowest, and that's going to be 85. Okay, this was the free response section that I gave you to be able to practice, and this is not the exact same question you had, but it's 100% very similar. So this is labeled a normal model completely with z-scores. So z-scores are 0, 1, 2, 3, -1, -2, -3. This means 0 is the mean, and this means 1 is the standard deviation. You need to make sure you label 68% within 1 standard deviation, 95% within 2 standard deviations, and 99.7% within 3 standard deviations. Okay, if the mean height in a class of 6th graders is 62 inches, so I'm writing that down, with a standard deviation of 2, so I'm going to put 62. What's the probability that a student is more than 67 inches tall? So I have 64, 66, 68. So I know that's going to be here. This is what I'm looking for. So my z-score is going to be 67 minus 62 divided by 2. And that's going to be 5 over 2, which is going to be 2.5. So I can look at my z-score chart at 2.5, or I can use my calculator. So I'm going to write down the calculator stuff here. So which would be normal CDF. My lower bound is going to be the leftmost area that's shaded, where the boundary is. So that's going to be 67. My UB is upper bound, and that's going to be the rightmost area that's shaded. It goes off and off and off, so it's 9999. My mean is going to be 62, and my standard deviation is going to be 2. Now let's go ahead and put these. I'm going to show you how to do the z-score, and I'm going to show you how to do the calculator. So let's jump to the calculator. So menu, stats, distributions, normal CDF. Lower bound was going to be 67. Upper bound is infinity, so lots of 9s. Mean 62. Standard deviation is 2. Okay, and the value is 0.006.2, so it's pretty small. So which is equal to 0.62%. Okay, so if I look it up in the z-score calculator, I'm going to look up for the z-score. I'm going to look up for 2.5. So on that, you're going to look for 2.5.0, and you're going to look for your value. So let's go to let's go to a z-score chart. Okay, so I'm looking for 2.5. So 2.5 is on the positive side. And so I have 2.5. I'm just going to bring it to the bottom left of the screen. And that's 0.9938. But what that represents, remember, is 0.9938 is this. 0.9938 is this part. And that's from here to here. But I want the top part. So that's 0.9938. So I want 1 minus 0.9938, and I'm going to get the same thing of 0.62% or 0.0062. You're not always going to get the exact same percentage, but it will be close enough that you'll get the full credit because it's similar enough to be fine because the calculator is a little more specific. Okay, this one says, what is the height of the bottom 5%? So bottom 5%, oh, sorry, not 0. We're at 62. We're same one, 60, 58, and 56. Bottom 5%, we know that this is 2.5% because that's 95. So we know that this here is my value of my bottom 5%. So my z-score, let's do a z-score for 5%, and we're going to look that up in a second. And that's going to look at my observed value, which I don't know, minus the mean, which is 60, divided by my, or 62, sorry, divided by my standard deviation, which is 2. Or you're going to go to inverse norm, area, which is what you're looking up in the chart, 0.05. Mean is going to be 62, and standard deviation, which is going to be 2. So let's look at both of them. Okay, so if I do the chart and I'm looking for a z-score of 5%, remember that means I'm looking for the body of the chart. I'm looking for 5%. And you're just going to look for something as close as possible. Oops, on the wrong one. So 5% is down here, and I'm going to bring it 0.455, 5%. The closest one, I think, is this one here at 0.0505, which is here on the bottom right of my chart right now. And that is going to be negative 1.601234. It looks like negative 1.64. Yep, that's a 4 at the top. So you can see I tried to bring it here where you can see it. So look at the bottom right, and that's the 5%. And you can see the z-score all the way to the left is negative 1.64, and then go all the way up from 5%, and you're going to get 4. So it's negative 1.64. So the z-score is negative 1.64. And at this point, you would multiply both sides by 2. And so it'd be negative 1.64 times 2. And then add 62. And that's going to be my answer. And then if I did on the calculator, I would go to inverse norm. Stats, menu, stats, distributions, inverse norm. And I would put 5%, which is 0.05. And the height is 62, and the standard deviation is 2, and I get 58.71. If I did this here, 58. Oh, what's going on? There we go. 58.71 inches. So this one would be about 58.7 inches. And this one, if I put it in the calculator, I would put negative 1.64. Okay. Times 2. And I need to add, what did we say, 62 to that. So that's 58.72. So this was, 58.72. So you can see that it's a little bit different, but it's very much close enough that they're about the same. Okay, I hope that helped you, and good luck when you are trying to take this test tomorrow. Make sure that you use cheat sheets, write things down so you have a little a notebook page or something to use for your test tomorrow. Thank you very much.